Okay, please note down the next problem statement. Okay, this is the this is a system, and the rigid bodies are attached to this system in this manner. Okay. This is block A, this is block B, and as you can see, block A is resting on this inclined surface, whereas block B is not connected to this vertical surface. It is free. Okay. Now, what you are supposed to identify over here? Such type of numerical examples you have already solved, but over here, the given information, it states that block A weighs 300 Newton. Block B weighs 50 Newton. The coefficient of kinetic friction between the incline and block A, this is given as 0.2. Determine the speed of block A after it moves 1 meter down the plane starting from the rest. I will repeat. It says determine the speed of block A, that is VA, if it moves down the plane 1 meter starting from the rest, that is initial velocity is given as 0. So what we will do is we will notify the final velocity and initial velocity as VA and UA respectively. Okay. So UA is your initial velocity. Okay. And VA, let it be final velocity. Instead of that dash and all, we will say that U represents the initial and V represents the final velocity. Now, the next step is to draw the free body diagram associated to this. Okay, complete figure. If you have noticed the tension in this string, let me assume it to be capital T. Okay, this capital T will be constant throughout. Why? Because the pulleys are frictionless. Unless it is specified, you are supposed to assume it to be frictionless pulleys. And because of that, the tension force which will be developed in this string, which is wounded over these pulleys, it will be constant. Similarly, if you try to identify the force in this string, which is connected to the block A, let it be capital P. We have already discussed this case. If you remember, if such is the case, the free body diagram associated to this case shall be in this manner. Let it be capital P. This is your pulley system, and this is capital T, isn't it? Then the free body diagram associated to block B, it will be like this. Okay? It will have self weight, which is given as 50 Newton. Fine. Let the axis be in this manner. Positive X, this is positive Y. True. So to identify this P value, drawing the free body diagram is possible only when the complete system is in equilibrium. and because of which, if I say summation of forces in x direction equal to 0, in that case what you will say? P is equal to 2 times T, am I right? From this, it is very much clear that P is equal to 2 times T. Okay? So this will become 2T, correct? After this, once you have identified the force in the this thread or this rope, then the given condition, what it says, you are supposed to identify the velocity of block A if it moves down the plane by 1 meter distance. Displacement of this block is actually mentioned, and how much it is mentioned? It is mentioned to be 1 meter down the incline. This is what is given. Okay, so we know the direction of motion of this block A. It is moving in the downward direction. So let me assume the displacement of this block A to be SA. Naturally, the frictional resistance offered shall be in the upward direction. And yes, if we are drawing the free body diagram, we are supposed to take care of the all the external forces which are acting on the rigid body. So you are supposed to express or show the normal reaction associated to this block as well. Okay, so this is, let's say, frictional resistance F. For this case, okay, for this particular case, uh, since this is moving downward, what will be the movement of this block be? Naturally, it is going to move in the upward direction. Am I right? So this is, let's say, displacement of block B, which is represented by SB. This is the tension force associated to it. Okay? So this is how we can represent the forces which are actually available on the two blocks. So let us redraw this, because we will have to identify certain more parameters. Okay? Let this be x-axis, let this be the y-axis, right? You know this angle can be evaluated, tan inverse of 3 by 4. How much does this come out to be? How much is that value? Please let me know. What is this theta value? Tan inverse of 3 by 4. Yes? 36.866 something. So let's say 36.87. Right? This is the self weight of this block A. This is mentioned as 300 Newton. So this angle shall again be 36.87 from the geometry. Okay? So instead of showing this vertical force, you can show the components, right? So this will become cos component and this will be the sine component. Okay, 300 sine 36.87. This is 300 cos 36.87. Am I right? Is this okay? Fine. So if it is true, other things you are supposed to mention. So this is normal reaction A. We know that this is going to get displaced in the downward direction. Hence the arrow is in the downward direction. Frictional resistance shall be in the opposite direction of the movement. So this is frictional resistance which is acting in the upward direction. Let it be FA, mu K times NA. Correct? अभी यहाँ पे भी एक force है which is 2 times T, which we have already found out. So this completes the free body diagram. pertaining to the dynamics. Next. This is 50 newtons and this is the tension force. We know this is going to move in the upward direction as a V. Now we will try to develop the dynamic equation of equilibrium. So before that, we need to address the internal force, that is the kinetic relationship. Kinetic relation. What it says that the total internal work done should be equal to 0. This is what the kinetic relation it suggests. So let me know what should be the value of work done for block A, whether it is positive or negative. What do you think? And what should be the magnitude of it? Amount of work done by the force and the displacement. कितना रहेगा वो? 2t into SA, am I right? And what will be the work done magnitude? Positive, negative? What it should be? Naturally, displacement and force, they are in opposite direction, therefore it is negative work done. Then displacement and the force, they are in the same direction, so this will be positive work done, equated to 0. Okay? Therefore, what do we get? SB equal to 2 times SA. This is equation 1. Or I can write it as VB equal to 2 times VA. This is equation 2. Since kinetic friction, coefficient of kinetic friction is mentioned, in that case we will have to make use of the dynamic equation of equilibrium. Now we are in a position to set up the dynamic equation, but since some amount of work is conducted by this block A, we can directly make use of the work energy equation in order to find out the unknown parameters. So let us try to make use of this work energy equation and let us see what exact value or what exact equation can be formed. So second is work energy equation. Okay. So total work done, resultant work done equal to change in the kinetic energy, V square minus U square, isn't it? This is what is the work energy equation all about. Now you just try to understand that this system comprises of two rigid bodies, and we are supposed to take into account the contribution of both these bodies whenever we are using any kind of equation, right? So for instance, over here, if we are using work energy equation, the amount of work done by these two bodies, that those are to be contributed. So in the left hand side part of this equation, if I want to express the total work done by this complete system, then what it will be? It will be the summation of these two work dones. Okay? So let me know in which direction the work will be conducted. Let's say for block A, किस direction में जाएगा? So if I say this is x axis and y axis, or x direction, y direction, so work done will be in which direction? X or y? Yes. What it should be? Naturally, it will be in the x direction. Do you agree? Okay. Okay. So we are supposed to take into account all the components. Those are acting in the x direction, and based on that we are supposed to formulate the work done equation. Okay, so let me know if I want to consider the work done by this block A, how many parameters will come into picture. So it will be this 300 sine component, it will be 2 times T, and it will be this frictional resistance. So there will be there are 3 components. So let me formulate those. Okay, so I am assuming this to be positive and this side to be negative, right? Based on that assumption, this will be 300 sine 36.87. No, over here I will have to consider the displacement value, isn't it? So for resultant work done, what I will do is the complete resultant of all these forces multiplied by the displacement. That will be our work done, isn't it? And uh, whether it will be positive or negative, that we are supposed to identify. Okay. So fine. ठीक है. I will consider this to be positive, this side to be negative, and based on that, this will be minus 300 sine of 36.87 plus 2t plus Fa into displacement is in the negative direction. So let me consider minus Sa. Correct? Then similarly, if I consider this to be positive, then plus T, these are the 2 forces and this is the associated displacement. So T minus 50 into SB equal to W by G, W by 2G into V square minus U square. Over here, as you can understand that there are 2 different rigid bodies. In that case, we will have to take into account the contribution of both, whether it is on the left hand side or on the right hand side. Those are to be considered. Okay. So for block A, it will be weight A divided by 2G. So final velocity VA square minus initial velocity UA square plus WB by 2G, final velocity minus initial velocity of block B square. Okay, is this okay? Next step is to identify this FA. FA can be easily identified by using summation of forces in y direction equal to 0. Okay. See, because this FA consists of mu k times NA value, and we are supposed to identify this NA before finding out FA. So if from here what I will get is NA is equal to, there is the only vertical component, other than this there is nothing, 300 cos of 36.87. So how much does this come out to be? कितना आता है ये? Please let me know. Okay, so let's say 240 Newton. Right? So 240 Newton. This will come out to be how much? 48. 48 Newton. So FA I have found out. Correct? Then just keep in mind that SA actually is given. SA is 1 meter. I have told you that this block A is moving down the plane by 1 meter distance. This is what is given in the numerical. So if SA is 1, from equation 1, SB will be 2 meter, as simple as that. So in this equation, I know SA value is 1 meter, SB is 2 meter. One more information I have. That information is related to the initial velocity. Correct? Initial velocity of block A. See what it is given. What it says. Determine the speed of block A after it moves 1 meter down the plane starting from the rest. इसका ही मतलब है initial velocity is 0. And since this is stable, the complete system will be stable, and based on that, UV will also be 0. But there will certainly be the final velocity associated to VA and VB as well. Right? If you look closely, there is a relationship between VB and VA from equation 2. Okay? So what is asked? You are supposed to identify the final velocity of block A. So convert that equation with respect to VA itself, right? So you substitute the value of VB in this equation, and how much it is? This is 2 times VA whole square. So I will rewrite the equation. Minus 300 sine 36.87, this is in bracket, plus 2t plus 48 into minus 1, because SA is 1, plus t minus 50 into 2. This will be positive because we have considered this to be in the positive direction, equal to WA. What is WA weight? It is 300 Newton divided by 2 into 9.81 into VA square minus 0 plus WB is 50, 2 into 9.81 into VB square. Now over here it will become whole square. I'm sorry, VA. 4 VA square minus 0. So you will observe one thing. When you expand this equation, you see this 2t and this 2t will get eliminated. Just try to expand this, and from that elimination you will get VA value. So can you please find out the VA value? Please calculate the VA value and let me know the answer. On the similar line, there is one more numerical. You can take this as your homework. Again, a system. Let this 480 Newton ठीक है. This is block A, block B. This block A is of 200 Newton weight, and one more information is given. The information is same but in different manner. So you can note down. Determine the distance. Determine the distance moved by block A. Determine the distance moved by block A after block B hits the ground. After block B hits the ground. The coefficient of kinetic friction is 0.2. Coefficient of kinetic friction is 0.2. And the pulleys are frictionless. And the pulleys are frictionless. Okay? So this is numerical which is very much similar to this. You are supposed to identify the unknown value. Right? Now we have discussed the impact equation, right? And in that impact, we have also came across the law of conservation of momentum equation. We have also came across the small e term, that is the coefficient of restitution value. It is nothing but the equation pertaining to the position of the of two rigid blocks before and after impact, right? Before and after impact. 1 minute. हाँ बोलिए. नाही. जिओटेक हाँ यावेळेस हाँ रॉक मेकॅनिक्स आलेलं आहे बरोबर. हाँ हो हो करेक्ट. जुने मुलं फर्स्ट सेमिस्टरचे आल्यात का? नवीन विषयांचेच केलेले आहे. विभाग जे आहेत ते नवीन ते हो चालेल. स्ट्रक्चर मध्ये जिओटेक मध्ये ते 571 होता आता 581 वगैरे झालं. हो हो 581 582 583 चालेल चालेल. ठीक है. So for that case, let's try to solve one numerical. We have also seen the different types of impacts. One was the central impact, another is the oblique central impact, right? So let us try to solve one numerical pertaining to oblique central impact condition. Okay? So there are two rigid bodies, you can say. They are moving with the help of these velocities which are acting in this manner. Okay. So what the problem suggests that in the oblique central impact shown in this figure, the coefficient of restitution is small e is 0.6. Then these are actually the flat disc. These flat discs slide on smooth horizontal surface. Compute the final velocity of each disc directly after the impact. Okay, you are supposed to identify the final velocity of these two disks after impact. So the initial velocities which are mentioned are 3 meter per second, and this oblique impact, it takes place at this angle value. Over here also you will find this is 4 vertical, 3 horizontal. The velocity is given as 3 meter per second. Okay, this is block disk A and this B. The weight is 50 Newton. And this is 100 Newton. Okay. So this angle is actually 36.87. This is 53.13. You can verify the angle. Okay. Now see, based on these oblique impacts or oblique velocities, you may experience two forces. One force will be acting in the horizontal direction, another in the vertical direction, isn't it? Since it is oblique, inclined, sort of. But the direction of impact, as you can see over here, it is happening in the horizontal axis only, not in the vertical axis. Okay? So let us try to identify what will be the change associated to such type of impact and how this problem has to be dealt with. So let's say this is the condition during impact. After impact, these two disks, they move along the same axis, okay? But the direction of velocities, let us assume it to be in the same direction. I don't know what is the final velocity or what is the final velocity direction. Okay, so let me consider VA and VB to be the final velocities, and these are UA and UB. Okay, UA, this is UB, initial velocities. Over here also, as I have stated, that there will be uh, two forces. Those will be acting. Let's say at the center itself. Direction of arrow is wrong. Over here, for A, the direction of this arrow in the x-axis. One minute. For A, this will be in this direction, and the y-axis will be like this, or the y component shall be like this. Whereas for this disk B, direction of the x component will be in this manner. You will agree. Okay? So based on the principle of transmissibility, I have instead of showing the components over here, I have shown it over here. Correct? Now, as you can see, this component, what will be the value of this component? It will be 50 cos of 36.87. Right? This will be 50 cos. So let me assume UAX to be the component in the x direction, which is 50 cos 36.87. UAY to be the vertical component. Similarly, UBX, which is 100 cos of 53.13, UBY 100 sine of 53.13. Am I right? So these are the components in the x and y direction. Correct? With respect to this, and with the information available for the coefficient of restitution value, that is small e. See, naturally, during impact, we will have to make use of law of conservation of momentum equation. So as per the law, what it says, initial velocity, initial momentum is equal to final momentum. So it can be expressed in these terms: WA UA in the x direction plus WB UB in the x direction is equal to WA VA x WB VA x. Sorry, VBX. My mistake, VBX. Okay. As you can see, the impact is taking place in the x direction. The law of conservation of momentum will be applied accordingly. And therefore, 50 into what is the UX? This value. How much does it come out to be? I am getting it to be 2.4. You please verify. Okay. Plus WB is 100 into UBX. Now UBX, as you can see, this is in the opposite direction of this. So we will consider this to be negative, and this value comes out to be 1.8. You can verify. Equal to final velocity, I don't know right now. And I am assuming that both are in the positive direction. This is what I am assuming. So therefore, these two values shall be positive. This is, let's say, equation 1. Then after impact, there will be separation, and this coefficient of restitution value will now come into picture. And as you know, the equation associated to the small e value, if such is the condition, okay, for that, this will be VB and a final velocity in the x direction minus the final velocity of of the disk A, again in the x direction, divided by initial velocity of disk B in the x direction, initial velocity of disk B, disk A in the x direction. Out of this, you know what are the initial velocities. Those are actually found out, those are calculated. So 0.6 is equal to minus VBX minus VAX divided by UBX. वो कितना है? Minus 1.8. So we need to be careful. VBX, although I have written over here is the magnitude, but the direction should be taken from this figure. This is UBX, this is UBY, UAY and UAX. Okay? So this is negative value, hence minus. VAX is actually, UAX is actually in the positive direction, so this will be negative itself, and the value is 2.4. You will get some equation from this, and then you can solve these two equations. Okay, once you solve these two equations, you will get VAX and VBX. Mind well, there is no change as far as the vertical components are concerned. Vertical components shall be same, because you can see the impact is in the x direction, and the movement associated to that particular impact will be again in the x direction. But since it is an oblique kind of impact, there will be y component as well. So over here, what you can say, VAY is equal to UAY. There is no change as far as the y direction is concerned. There is no change in the velocity, and therefore final velocity will be equal to initial velocity. तो इसका जो value है UAY का, that value I am getting it to be, that is the initial velocity value I am getting it to be 1.8 meter per second, and VBY will be equal to UBY, which I am getting it to be 2.4 meter per second. And since both are in the positive y direction, this will again be positive y direction. Based on my calculation by solving 1 and 2, I am getting VAX value to be, that is the final velocity of A in the x direction, I am getting it to be minus 2.08 meter per second. And VBX I am getting it to be positive 0.44 meter per second. Okay, these two values I am getting. So now the picture is clear. These are actually, if you look closely, these are the components of a force. Okay, so if I take into account A value, VAX is negative this direction, and the magnitude is 2.08. VAY is positive, magnitude is 1.8. Based on this, you can definitely calculate the resultant value, which will be your final velocity VA. And similarly for VB, these are the two components. So as you can see, x direction component is positive, magnitude is 0.44 meter per second, and this is again positive, this magnitude is 2.4. From this you can get the resultant value B. You know how to calculate the resultant, and since it is an inclined value, value, you are supposed to identify the associated angles. So this is how you are supposed to identify the final velocities, and from here, as you can see, my assumed direction of VA, which was positive, is not true. It is going to move in the opposite direction. This is going to move in this direction, and VB will continue moving in the positive x direction. Okay, so these are a few numerical examples, and this portion will complete your dynamics chapter as such. You are supposed to practice different numerical from different references which I have given. Try to solve them, and in the next class we will see the component of vibration. That thing I will be showing you in the PPT format itself, right? So that PowerPoint presentation will be displayed to you all. Okay, so I will stop here. You people can leave. Thank you.